Welcome back. Today we're going to be looking at how to make a line chart using Plotly, and along the way we're also going to learn how to import data from a file so that we can use it in Plotly within the MoLab system. And then we're also going to see a little bit of how we can explore online documentation for Plotly for understanding how we can control the appearance of plots. So today we're making a line chart. We have a new notebook, so as always, let's just give it a title that's descriptive so we can find it before. Let's get started. We know that we typically use this Marimo. We haven't really used it, but it's fine to have it included. We know that we're going to make something in Plotly, and so we can say from plotly.subplots import make subplots. This is how we normally do things, and this will be just fine for us. If I run this, we get access to Mo and access to subplots, and so we would start making a figure. So we've got figure equals make subplots, and then we need to add some data. We're going to be making a line chart, and so we would say fig.add, and you might think it would be add line, but it's not. It's add scatter. And so from the perspective of Plotly, a line chart and a scatter chart are the same thing. It's just that, like in a line chart, we connect the data with a line and we don't show the individual markers. So that's what we're going to do. Because it's a scatter plot, we're going to assign X and Y values. And so we need data. Now, in the past, as we've added data in, we've done it just by manually typing or copying and pasting it. But there are other ways to do it as well. We can use files instead. And so, for instance, we're going to make a line chart from the data shown here. We examined this data early on in the course, but if you want to see it again, we can go ahead and open it. Before I opened it in Sublime Text, now we'll open it in the built-in application here in Windows. This was the data that we were interested in. Adding this to MoLab is pretty straightforward. You'd go to the file system, you say upload file, and then you can navigate to where that is, say open, and now we have this CSV. It's given this symbol over here that is like the symbol of a database, so it's trying to tell you that there's data contained in here, or at least it thinks so. And if I click on housing, income, and education, then you'll see this is the information that it sees. We have these 4 columns: year, education percent, income percent, and housing percent. And so it's also able to parse these CSV files. There's just a single page, so there's nothing else we need to do with this right now. What we would like, actually, let me go back. What we would like is to use the year as the X, and then make 3 different lines for education, income, and housing. So let's just start by making a plot of the year and the income percent change over those years relative to 2000. That's what the data is here. So how do we do that? Well, I'm going to click this button to make a cell above. It actually doesn't matter from Marimo's perspective whether the cell is above or below, but I think since I'm a human reading this, it can be nice to keep them in the order that I'm used to seeing them, unless I have a reason to do otherwise. And so let me say that this is change over time is the data. We need to somehow get all this data into here. And the way we're going to do it today is we're going to use another library called Numpy. So we're going to import Numpy, and we're also going to give this an alias MP. We're going to use a function from Numpy called genFromText. And genFromText is a way that we can generate NumPy arrays, which are similar to lists. We'll talk about the difference just very quickly in a moment. And we can obtain it from a file, And then we have ways of parsing the file to get that information back out. So let's just use it. And if you're interested in how it works, there's lots and lots of documentation for this online. So what we need is to know the file name. So I will just say, we're going to import from this file, housing, education, and you can see that Marimo's actually aware that this exists, so I can just click on there. It'll autocomplete. We need to tell this not only where it's looking for data, but how we're going to parse this data. All right, so let's have another look at this data. We can see that there are 4 rows, and we know that the thing that's separating these variables from one another is the comma. And that's what people call a delimiter. So we're going to tell this function that we have values separated by a string, comma. And then the other thing is that when computers read files, they typically do this row by row by row. And we don't want rows, we want columns. And so the way to tell this function that I don't want rows, I want columns, is to tell it to unpack. What we're saying is there's multiple values in each row, and I want you to unpack those values into columns. That's essentially what this is. And we'll come back to this idea of unpacking in just a moment. So this is all we need. Now we're going to take the information from this, we're going to put it into rows. We're going to collect all those rows together and put it in a variable called change over time. I spelled delimiter wrong. Okay. Now we have change over time. And if we went and looked here at the variables, we would see that I have change over time. And it tells me that this is an nd array. So that's a Numpy array, let's say. Okay, we can also see that it starts, if we look at the values, with NaN. NaN is NumPy's way of saying this isn't a number. If we go back and look again at our files, we can see what's happening is that the first entry was this heading up here. And these aren't numbers, and it has no way to control, no way of knowing that that's going to be not a number. And so when it encounters something that's not a number, it converts this to the NaN. We could tell it that there is a header, and so we could just say skip, and you can see that it's suggesting what we might use. Skip header equals 1. So we're going to say let's skip the first row. And now when I run this and go back and look at our variables, you'll see that it starts with 2 times 10 to the third, or 2000. And looking back at our files, that is in fact the first value that I expect for this first column. So now we're getting all the numbers in. One way to explore the variables is to go ahead and look at this, but we can always just come in and say print change over time. When I run this, now what you'll see is I have nested values. Essentially, I start an array. It looks a lot like starting a list here. And then I immediately start another one. I put a series of values into it, and then I stop that array. Then I start a new array, a series of values, stop the array, it's a new array, series of values. And so what you can see is that I have one array that's holding 4 other arrays inside of it. If we wanted to, we could check that. And so there's a function for just telling me how many items are inside something like a list or an array. And so I could say print length of change over time. And what you'll see is there's 4. So it told me that there's 4 arrays inside of here. Now, what if we wanted to access just one array? Well, it turns out that we can refer to them by sort of like the number of the array, knowing that Python starts at 0 when it counts. So this first array is the 0th array. The second array is the first array, second array, third array. So it's array number 0, 1, 2, 3. These are called indices, and we can select them by placing the indice between square brackets. So if I wanted just the first array, and then I wanted to know how long that array was, I could do something like this, where I'm saying use the very first value, the 0th array. And now you'll see that when I run this, I only get the values that are associated with the years. If I go back again and look at the file system, we see that the first array, that is the years. That's the first one I expect to see, and that there's 18 total values. And then if I looked at the second array, what is going to have index number 1, we'll see that I have 0, 3.3522. That's exactly right. And so this follows along here that this is education percentage, and this is 18 long as well. And this is good because if we're going to plot line charts, we need the X and the Y's to be the same length. So now we have a way to add scatter. Let's go ahead and do that. I'll say the X values I would like to be change over time, that first array, comma. The Y values I want to be change over time. And we said we should plot income array starting at -2, -3, -3, and that's what we have here. -2, -3, -3, and so on. So now we've plotted what we wanted. We could change the appearance of all of this, and we will in just a moment, but let's do a few things first. But we could also try to give them names that make sense. For instance, when we imported this change over time, what we really wanted to get out was years, something about education, something about income, and something about housing. So those are the 4 different values that we were interested in, or 4 different arrays of data. And what I can say is that's equal to change over time. The reason I can do that is because this change over time variable had 4 different values associated with it, or 4 different arrays. And so if I go back and I erase the index here, I can remind us of that. It was 1, 2, 3, 4 different arrays. So it had a length of 4. And what we're doing when we say 1, 2, 3, 4 different variables assigned to this variable is we're performing this unpacking operation again. What we need to do is supply as many variable names as there are elements inside of this particular series, which again is 4. So I needed 4 different names. And when I do this, I will have created new variables. And now I have years, and you can see that the years contain 2000, 2001, 2002, just as I expected. And then the income is -2, -3 here, just as we expect for the income. So once we do that, we can actually give these a little bit more meaningful name, years and income, and then it's a little harder to mess this up. And we'll get the same result here, but we could change this to housing if we wanted, for instance, and get the trends associated with that. All right, you'll see that I bumped my mouse and zoomed in on this figure. If you don't want that, you can just double click somewhere inside of here and it'll go back, or you could have pressed the home button to reset everything. Either one is fine. All right, so let's go back to income. We have this basic plot. We would like maybe to explore a little bit how to make it better. We already know how to change many different aspects of this. And so let's go ahead and change what we normally would want to. Let's say fig.update layout. I usually, again, like to use a template that is the simple white template. You have to spell it right. And then I'll have something that looks pretty basic like that. These axes are not labeled, and so we need to say fig update x-axes, and then I like to give them a title maybe. Let's try years. We'll discuss whether we really need that in this case. Fig.update y-axes, title equals percent change since 2000. All right. Now our axes have titles, and that looks fine. We can add an overall title, so that would be under the layout. here we would say from 2000 to 2018, income was relatively flat. I mean, we did lose some income, it came back, and it didn't change too much. The reason that this didn't run is that there is an error. It says syntax error, invalid syntax. Perhaps I forgot a comma, and I sure did. I forgot to separate these two arguments, and when I do that, done. Again, we could align this. We're not going to do that today. We've demonstrated how you would align a title, and so I'm going to assume that you know how to do that now. Instead, we're going to focus a little bit more on this new thing here, this line chart. Now, first off, it's not really a line chart. It's a scatter chart where the markers are connected. So let's go ahead and change that. Under scatter, we can control whether we have just lines or not. And this is done using the keyword mode and then supplying it the string lines. So we're saying, I don't want markers, I just want lines. Our other options are lines, markers, and this doesn't have the word lines, so we'll just have the markers and not the lines, or markers plus lines, and then we have both. So that's what we started with. The default in Plotly is that it looks at how many points you have and decides whether it should try to show markers or just lines or anything like that. So let's go back, and we wanted a line chart, and so there it is. Now we have control over lines, and one thing I want to point out is that the markers were showing up where the data is. The line feature is connecting those data points. And so this particular kind of line is not a marker, it's a line. So if we want to control this, we use the dictionary line, and then we can supply it values. Now, what values can we supply this? As you might expect, something like color. And so again, we can give this a named CSS color. We know that already. So there's red, color, width. We had seen this when we thought about tick marks, that we called the width of the tick marks a tick width. So width is just what we use for lines. So we can make this a very bold line if we wanted. And then we also have a new style called dash. And in the dash, we can have something like dot, and we'll get dots. We could have dash, and we'll have dashes. We could have long dash, and we'd have longer dashes. And then the default, what we started with, was a solid line. And so we also have solid as an option. Now, again, we're starting to get into a case where there's many different options that are present here, and it may feel like it's hard to remember what they all are. Again, you can always go and talk to the AI agent and have a discussion about what's possible to do here and what's not. Something else is that as you get more and more used to using Plotly, you can go read the Plotly documentation. So for instance, if you go to the Python API reference for Plotly, that's what we're using. So we're in Python. API stands for Application Programmer Interface. And so it's a way for the programmer, which is you, to interface with the application, which is Plotly. And then if we scroll down, you'll see that there's a list. There's a bunch of stuff about Plotly Express, which maybe if you've been using the internet or the AI agent, you have encountered. I've tried to avoid it because it does hide many of the details, and we're trying to learn the details right now. Later on in this course, we'll use it for a few examples just so that you can see it. If you keep scrolling though, you get to graph objects. And this is really kind of where we're living right now. We're dealing directly with the figure, and then we're doing things like adding these simple traces. Right now we're adding a scatter trace, but we've done things like add a bar, and we've done things like adding a pie. So we're making a scatter plot. I can click on scatter, and it takes me to this, Python graph objects scatter. And then you can see the parameters, or what we're also calling arguments, that you can supply to it, right? So we've been using X and Y. And so if I scroll down through this huge list, then we'll eventually encounter X sets the X coordinates, and Y would say sets the Y coordinates. We also introduced the idea of using a line and using mode. So we'll find both of those. Mode determines the drawing mode, right? And so we can have lines or markers, or lines plus markers, or markers plus lines. Actually, the order doesn't matter for how we specify both of them. And then we were controlling things by using the line. And so we can provide a dictionary that gives us information about how we want the lines to behave. And when it's also telling us that this is an instance of Plotly, the graph objects, scatter, line. If I click on this, it'll take me to a new part of this documentation. I mean, this page is very, very long. If I scroll up a little bit, here it is highlighted. We're talking about Plotly, graph object, scatter, and then line. And it's telling us that what we could supply for this is back off source, dash, which we've used, shape, simplify, smoothing, and width. And then also color was in here. And so you could read about all of these, sort of like what they do and how you might use them. We're not going to explore any of these right now, but here's color. Tells us that we could supply it with a hex string or a named CSS color. And then here's the actual list that Plotly has. So if I click on this, then it'll have a whole bit of information about what colors you can actually use that are named in Plotly. All right, so then let's go back. Dash, you can see it's solid, dot, dash, long dash, dash dot, and long dash dot. Those are our options. And then we have the ability to control how long the dashes are directly if we wanted to. And so you can play around with that or chat with the AI shape. Okay, something else that's of interest that we're gonna show is this shape, all right? And in shape, we have linear, spline, HV, VH. So we had shape. We don't normally think of shape and lines maybe necessarily. I mean, it's just a line. So what is this doing? Well, when we draw a line, there's some interpolation between the points, and it's telling me, how is this done? All right, so let's go back and let's just see what happens as we change it. So shape equals, and then I guess we had linear was an option. That's the default. So that's what we were used to seeing. There was line. Now we get this sort of rounded line. So what is happening is, if I go back, I'm just going to actually comment this to get rid of it. There's different points. And in the linear one, it basically takes one point and another one and connects it with a straight line. When I use spline, what's happening is that it's looking at several of these points and then creating what's called a spline, which is sort of a smooth curve connecting them all. And you get this smooth looking line. I don't like this. In general, I think there's not a good reason to do it. There may be some edge cases where it makes sense, but for the most part, I think this smooth line invites a lot of trouble in people understanding what you're showing them. And in some cases will severely misrepresent your data. All right. We also saw that it was like HV. All right. HV, what you can see is that it's basically going horizontal, encountering a point and then dropping down to that point, going horizontal, encountering the next point, and dropping down. And so this is emphasizing sort of the step function nature that we could have in some of our functions. When we had the linear interpretation, like this, it kind of implies to us that things were just changing smoothly the whole time between these points. And that's not really what happened. Instead, somebody measured the price of, or the amount of income people were getting in 2002. And then in 2003, they measured it again. And then in 2004, they measured it again. And so using something like HV or VH, you know, that's sort of the relative order, whether we go vertical and then horizontal or horizontal and vertical, will emphasize the fact that you're basically just making measurements and then it changes in this like step function every time you make it. Now in this particular case, I think it was probably fine to have the linear, and so we can go back to that. All right, so now we know how to control a lot about our line, and we know how to go back and look at the API and read up on how we might change it. And of course, if you're working with an AI agent, what you could do is you could say, I'm trying to understand, like if it doesn't quite make sense what's going on with shape, you can just say, look, I'm looking at the shape property and lines for Plotly, and I'd like to understand more of how they work and why I might use one or another. So the last thing I think we might want to do is add these other two traces, the ones that aren't just income, but are also housing and expenses. And so something we could do is just take how we added the first one and then add two more. So we would have housing and education. And now we should have 3 lines. You can see that what we have here is now a legend being built up. We know how to not show the legend if we wanted to. And we know, but we don't know how to directly label the lines when we don't show the legend. But later on in the course, I'm going to expect that you don't have these legends. Okay, so we can't tell these apart very well, and this legend doesn't really help us with trace 0, 1, and 2. So the last thing we're going to do is make these lines look different. And so let's just say that this is light blue. How about that? And usually these don't have spaces between them. And how about light green? I'm not sure that green and red are great choices right now, but there we go. I can tell these 3 things apart. You could also give them different widths and different dashes and things like that. That is all discussed in an article on the accompanying website. And so you can look into that. Again, we're not trying to make beautiful looking plots right now. We're just exploring what are our options and making sure we know how to use them. The last thing we want to do is have names that make sense. So the thing that controls that, or the keyword for that, is name. The name equals income. And so if I type that in and run this, what you'll see is it says income now next to the red line. So we just need to do this for the rest. Name equals housing. Don't forget to put a comma at the end. And then name equals education. And then when we run this, we'll have a legend where everything lines up correctly. Okay, again, this isn't necessarily beautiful, but we have learned a few things. One, how to bring in data from a file, how to handle that data, how to create lines, and how to control the appearance of those lines, and finally, how to name the different traces that we have. And that's everything for this particular video.